Alright folks, I'm going to show you how the simulation system works, which is an important feature that was mentioned for this project. So I'll demonstrate using the virtual GTD how we would handle the simulation system for you. So here I have this little lightning bolt, and when I click on it, I have several simulations here. I'll give you an example. I'll show you, for instance, how the substation is right now. For example, at this point, it's currently with both of my transformers connected in the circuit, both on the high and low sides here and here. So what am I going to do? I'm going to apply simulation 6. We can give this simulation a name, okay? At first, it was supposed to be a challenge, right? You would trigger the simulation without saying what it is, and the person has to figure it out. This is customizable. So I'm going to click here. Here I'm saying that it's going to be a shutdown with transformer blocking protection. So it's going to start the simulation here. And I open the circuit breaker here for transformer 2. Then the power flow is completely recalculated. The current now flows entirely through transformer 1. But what I want to show is the following. In the simulation, we have an automation here in the substation, which works like this. When both transformers lose power, when both tertiary windings here are without voltage, my auxiliary service will supply power to the entire tertiary of transformer 1 and transformer 2. If I lose both of these sources, then I need to bring in the emergency diesel generator. And so the emergency diesel generator is monitoring the voltage on the bus bar. So now I'm going to run simulation 7. What does simulation 7 do? It opened the circuit breaker, 0 amperes. I have no voltage here at 13.8. My 380 bus bar is at 0. So that noise means the diesel has started up. Look at the smoke over there. So if I go over there, the diesel is running, it's operating. And now to power this bus bar, I need to close the bus bar circuit breaker. Once that's done, I supply my 13.8 auxiliary service. And then I can bring my substation back online. I have the lockout on, just to be sure for safety reasons. '86, and my supervisor is telling me every day that I have the '86 lockout. So guys, I need to solve this out in the field. I have to reset relay '86. I'm going to reset it now. I'm going to close my circuit breaker. I'm going to open my GDG at this moment. And now I can safely shut down the GDG. I'm going to come over here. I can switch the control to manual, set it to local mode. I'm going to shut down my GDG and let me check how my supervisory system is doing. Let's see if I perform the maneuver correctly. I also need to energize the low side of the transformer. I have to reset relay '86. The command is locked. Probably because I don't have the necessary auxiliary service electrical power to operate the circuit breaker. What am I going to have to do? Start the diesel again, connect it to the bus bar. So all of this, folks, is just maneuvering. I'm going to start it locally. I'll come back here to this familiar place and then start my diesel engine again. Close the circuit breaker. Actually, I'll close it from here. I've powered my bus bar. My bus bar is energized. Now I'm going to try. The breaker is still locked. It's released. The automation has released. I've closed my circuit breaker. Now I've managed to decrease the number down to a total of 380. The automation has already switched both circuit breakers. Now I'm going to shut down my diesel. And now I have current here in my auxiliary service. I've normalized the substation. So all of this, folks, was based on a simulation. And you can see that the whole system is recalculated. So I'm going to give another example. Here, all my load is coming through this transformer. I'm going to unlock my 86 and close this circuit breaker. And the load is recalculated. It drew 13 amperes, probably because of the auxiliary service configuration. Here, transformer 2 was left with the essential loads, while transformer 1 was left with the non-essential loads, and that is the reason why the load is relatively low on the transformer in this scenario. And then there's tap changing, all of that affects it. Let me give another example here. Bus reactor. If I open the bus reactor circuit breaker, the voltage will rise. So the voltage goes up. If I close the capacitor bank, the voltage will rise even more. It went up to 200. All of this is calculated, folks. So for example, I can run a simulation where I open capacitor bank. If I'm not mistaken, it's the first one. Shutdowns of the capacitor bank. So I start the simulation. Here it is. It opened, the capacitor bank opened, and then I have to go back and reconnect the capacitor bank. Anyway, that's how the simulation system works, folks. I start the simulation. It opens. It does what it has to do, and then we have to interact with the system and redo it. I executed all the commands through the supervisory system, which is the main way to operate remotely. However, we can also perform these commands locally, right at the equipment, such as opening and closing the circuit breaker by hand. So now I'm going to give a local command here, for example, to demonstrate. So here I have the control panel in front of me. Of the circuit breaker refers to this line. In the diagram, it's circuit 2. This circuit breaker is 523 here. So I'm going to open the panel, switch it to local, and open it. The indicator light is green. If I check my supervisory system, it shows the circuit breaker is open. Now I can operate, for example, a disconnect switch. I'm going to operate this switch here. I'm going to close it. 8914 is this one here. I'm going to close it. I pass my local remote key, making sure it's right here for local use, and then I press the close button. I'm going to look up here. It's closing. I'm going to open it. Open. And folks, it can also happen that a wrong maneuver is performed. So I'm going to turn off the circuit breaker. Okay, it's already turned red. I'm going to open a load break switch. Let me locate a disconnect switch. And I'm going to open that disconnect switch that's in charge. So I'm going to open her panel 8912. 8912 is locate 8912. This one here just upstream of the circuit breaker in the electrical system. If I open it under load, something should happen. So that's the effect when opening under load and the game notifies you. Oops. Maneuver error. Disconnect switches cannot be opened under load. I click reset, then it returns to normal. And then I can restart my maneuvers. So folks, this is the simulation system. Now I'm going to show a bit about the primary substation, some operations in a primary substation. All right, folks, this is our primary substation scenario. Here I have a 38380 primary substation, and here is a factory. I'm going to show, for example, a bit of the factory. So there's a factory here with motors. The motors here are running. The shaft is spinning. You can see it here. I also have an elevator here. If I come over here, I can see it running. And I also have some teaching panels. So for example, I have a panel here that when I hover the mouse over it, it tells me what the equipment is about. So here I have an electric motor, and if I press the letter I pull up its information. It brings up a PowerPoint presentation, everything related to this equipment. Since this is a video, I can actually show you a video or display a photo or even present a PDF document all about that specific equipment. Here everyone, I have a panel of circuit breakers in front of me. So take a look. The power factor is currently 0.9. On this panel, for example, we can see our power factor, active power, reactive power, and then observe what happens. For instance, if I turn off, say, a piece of equipment, notice that all the motors are currently running. You can see the changes that occur. The power factor is recalculated. The voltage and current here on the gauge are changed. So I'm going to turn off more things. So look, the power factor became 1. This here, folks, I'm operating capacitor banks. I'm going to turn everything off. My power factor dropped to 0.73. And I have an increase in current. If I try to balance my power factor, my current drops. Anyway, folks, that's a matter of power flow. Now I'm going to shut down the factory from my primary substation. So I'm going to get to... I opened my substation, and here's something interesting. If I press M and click here, I have energized conductors here. Now I know it's energized, it's red, it's energized. What I'm going to do, folks, is simply open the circuit breaker. Now it's green here. Green here. And if I come here right now to my factory's panel, my voltage dropped all the way down to 0, and the current is also 0. I have absolutely no voltage or current anywhere in the factory, and everything has stopped. It's off. The motors, look, the motors are off. They're not running at all. This one here, my elevator, has stopped. So I can, for example, simulate a transformer switching operation. There are 2 transformers, they're in parallel. I can take one out, I can take the other out, bring one back in. So here's what I'm going to do. I'm simply going to open one transformer, open my panel, and energize my... I closed it, it turns green here, and the other transformer, it also, oh, it was open, so with both switches open, there's no way it can work. So I'm going to open my circuit breaker. I'm going back, I'm going to close this switch here. They weren't in parallel, the two transformers. I'm going to come here, close my circuit breaker, energized it, listen to the sound of the transformer, and it's energized. And why did it energize, folks? The bottom part of this transformer here is the return. It's the voltage return that comes from the panel. It doesn't mean it's connected to the grid, it's just the voltage return. So the voltage passes through this transformer, goes to the panel, and comes back through here, but that doesn't mean it's operating. Well, folks, this is the primary substation. Here we have the CTs and PTs. Anyway, everything needed to give a lesson about the primary substation. And contingency simulations like the one I did here. I can create simulations saying, look, I lost the capacitor banks, the circuit breaker protection was triggered, or this transformer here caught fire and I have to switch the power source. Anyway, the simulations will be carried out strictly according to the specific needs and requirements of the client. Well, folks, that's what I had to present to you today, and I sincerely hope you understood how the entire process works, and that's exactly what we're offering to do for the door network, providing our expertise and support throughout the implementation.